To solve this first example, it's a simple problem in which, first of all, you need to get your u, which in this case is cosine of 2x. Then, in order to get the du, you need to get the derivative of that same term, which is negative 2 sine of 2x. Then, to start solving the problem, you need to get the inverse of the whole term. So you get negative 1/2, and you then sum 1 to the exponent and then divide it by the same number. So you will get negative 1/2 your term divided by 3 and a 3 as an exponent. Then you solve it, and at last you just add your constant, which is c. For this quick example, we have already got a definite integral. So this means that negative cosecant is our integral, and in order to find the answer, we just need to add the inverse of the derivative of 3x and then solve, and you have the answer.
In this example, we have sine squared 4x and cosine squared 4x. In this example, we have to use the trigonometric identities because of the exponents. These are the trigonometric identities. The ones in red are the basic ones, and the ones that are used for pair exponents are the ones that we are going to use right now. Back to the example, we will use the formula of sine squared. We put 1/2 times 1 minus cosine 2 times the angle. Then we get the inverse derivative of 8x. There is 1 over 8. Then we multiply the 1/2 times the parentheses. Then we integrate each one. The integral of 1/2 is 1/2 x, and the integral of cosine is sine. Finally, we add the constant. In the other one, it's exactly the same, but with the sign positive because of the formula of cosine squared. In this example, we have an odd exponent, that is sine to the third 2x. We are going to separate it by 2, that is sine 2x and sine squared 2x. We go to the trigonometric identities and we use the one in blue that says sine, that is 1 minus cosine squared 2x. Going back to the example, we multiply each term using FOIL and we get sine 2x minus sine 2x cosine squared 2x. We use the derivative to eliminate sine 2x, and we add the inverse of the derivative, which is 1/2. Then we will add 1 to the exponent of cosine 2x, and it's now going to be to the third power. And also we divide it by 3. Finally, we integrate each variable, and we get the negative 1/2 cosine 2x plus 1 over 6 cosine to the third 2x plus c. This other example, we are applying 1 with a pair exponent and an odd, sine squared 2x and cosine to the third power 2x. We substitute the cosine to the third 2x for cosine 2x and cosine squared 2x. We will get the derivative of sine by moving the square multiplying all. The derivative is 2 cosine 2x. Then the inverse is 1/2. So now we have 1/2 sine squared 2x and cosine squared 2x. Now we will see which trigonometric identity we will use. We will use the one in blue of cosine, that is 1 minus sine square of angle. Back in the example, we use FOIL to each term and we get 1/2 times sine squared 2x minus sine 4 2x. Then we add 1 to the exponent of the two terms and we get sine third 2x over 3 minus sine fifth 2x over 5. Finally, we multiply by 1/2 each one and we get 1 over 6 sine to the third 2x minus 1 over 10 sine fifth 2x plus c.
In the past examples, we saw how these problems were solved in a more or less equal way, but this doesn't mean that they are exactly the same, they have differences, such as the use of evens and odds in the trigonometric identities, and in the other examples, such as the direct applications, are the cases in which we add 1 to the exponent, and that we also use the integrals that we already had in the problem. So these are the differences between the two examples and the different problems.